All right, section 8.2 today is graphing simple rational functions. When we talk about the word rational, the first word that should come to mind is fraction. And I know sometimes fraction can be a bad word, but that's exactly what you should be thinking when you think of rational. Anytime they say the word rational, you should be thinking fractions right away. So when we look at graphing rational functions, or the terminology rational functions, it's going to be something like f of x equals p of x over q of x, or two things that are, one's on top, one's on bottom. And there's different things when we talk about rational functions, what they're going to look like. The graph of a parent function f of x equals 1 over x, that's a hyperbola, or a hyperbola. Hyperbola makes you sound a little smarter. Which consists of two symmetrical parts called branches. And we're going to graph this in just a minute, but you need to know the terminology. They're called the branches. The domain and the range of this thing would be all non-zero reals. All non-zero reals. Sorry for the, once again, terrible handwriting. The asymptotes would then, if they're all non-zero reals, things that are not zero, the asymptotes would then be x equals 0 and y equals 0. Where it does equal 0 is where it couldn't exist. And any function of the form g of x equals a over x, where a can never equal 0 in that situation, has the same asymptotes. If I can get all this to fit. Asymptotes. Oh yeah, I'll do this. And domain and range. And so I go with domain and range. How about that? As the function f of x equals 1 over x. And so as long as it's in that form, they'll always have the same asymptotes, 0 and 0, in the same range, all non-real zeros. So let's take a look at what that might look like in graphing form. When I graph the function y equals 4 over x, I can draw my asymptotes right away. And so my asymptotes, remember, were x equals 0 and y equals 0. So to have asymptotes here, I'm gonna put these in red. My asymptotes are going to be right here and right here. Red meaning stop. Red meaning you can't go there. Plot the points to the left and to the right of the vertical asymptotes, such as, and so what I'm going to do is I'm going to put -2 in there and see what I get. So I'm going to switch back to green for just a minute. And so when I put -2 in there, I get y equals 4 divided by -2. Well, 4 divided by -2 is -2. So I have the point -2, -2, a little dot right down there. If I put -1 in there, well, 4 divided by -1 is just -4. So if I have -1, 2, 3, 4 is right there. If I put a 1 in there, I get a regular 4. If I put a 2 in there, I get a regular 2. 1, 1, 2, 3. There's my 4, and 2, 2. Right there. Well, this thing, when I graph it out, is going to look like this. And hyperbolas look like that, and those are called the branches, as we talked about up here. It's a hyperbola with branches, and all the x's can be everything except for 0. And so when we talked about that, those asymptote lines right here can't ever reach those. Gets close and close and close, but never ever touches. When I take a look at the next checkpoint, I want you guys to go ahead and do that. And some points that you might want to choose for x, you might want to include, -1, -3, 1, and 3 would give you some good points. So go ahead and do that. All right, welcome back. Hopefully when you put -1 in there, you got -3. When you put -3 in there, you got -1. 1 in there, you got 3. 3 in there, you got 1. So you ended up with points at -1, -3, and -3, 1, 2, 3, -1. So your graph looked like that. And the other side looked the same way. All right. Now, when things translate, and we've talked about this a ton of times in this class, well, the h and the k are always moving things around. So we have these translations of h and k and how it always affects our current situation. The graph translations of simple rational functions. Now remember, if that center point, if you think about the center point being 0, 0, those two asymptotes, h and k is going to move that to the left and to the right and up and down. So the graph of a rational function of the form y equals a over x minus h plus k follow these steps. Well, if the asymptotes before were x equals 0 and y equals 0, now they're going to be x equals h and y equals k. Plot points to the left and to the right of your vertical asymptote, where your vertical asymptote ends up being that x equals h there. So we can just say vertical asymptote because we know what we're talking about here. Okay, and then you want to draw the two branches. And so let's go through and see what that might look like. Draw the two branches. So let's take a good look at example 2 here. In example 2, I'm first going to plot that point. Now, if it's minus h, remember it's just the opposite. So this might have said originally, or did say originally, x minus -3. So my h is x equals -3, right? 1, 2, 3, right here. Let's make that red again, so we're all on the same page with that. All right, and that k in this situation would be 2. 1, 2. Oh boy, I messed that up, didn't I? They're counting by twos. They're counting by twos. All right, let's try that again. All right, let's do that again now. So they're counting by twos, and I have red, and so instead of where I was, I want to be right there would be -3, and right here would be 2. And make sure you're always looking at what they're counting by, because that could be important. Now, when I graph that, and I draw my asymptotes, now what points do I want to choose? What points do I want to choose for what I'm doing here? Well, remember the x asymptote was at x equals -3 and the y was at 2. So I'm going to pick points to the left and to the right of -3. So they picked -6, -4, -2, and 0. So they picked some that were over here and some that were over here. Some were on this side, some were on this side. All right. If I put a -6 in there, I get -6 plus 3 is -3. -6 divided by -3 is 2. 2 plus 2 is 4. So if I go over here, 2, 4, 6, and 4, I'm right about there. I have a point. So it looks like my branches are going to be in this sector. Well, because that leading coefficient was negative, that would make sense. Everything's going to flip upside down. When I put -4 in there, -4 plus 3 is -1. -6 divided by -1 is 6. 6 plus 2 is 8. -4, 8. 2, 4, 6, 8. And I draw my branch. Okay? And I do the same thing when I put my -2 in there. I get a +1. -6 plus 2 is -4. So I have -2, -4. It's down here. Right there. And if I put 0 in there, -6 divided by 3 is -2. Ends up being 0. So I have the point actually 0, 0. So this looks like that. Okay. Draw the two branches of the hyperbola. So I already did that. The domain of this now would be all real numbers, but you couldn't have negative 3 because you can't have a 0 on the bottom. So all reals not equal to negative 3. And the range of this thing, if you look at your asymptote right there, that red asymptote going back and forth right here, and I just turned it to green, that's at 2. So this is all real numbers, but you'll never get to a 2. All right. Now y equals 4x minus 2 over x minus 1. I hope some of you right away when you see that say, oh, look, Mr. Emiot, look, you can't have a 1. I know this. You're going to have an asymptote at x equals 1 because I know that it will never be 1. So get out your red pen, Mr. Emiot, and let's just draw it right now. Because that's the first thing I know when I look at this thing is that x can't be 1 because I can't have 0 on the bottom. All right. So that vertical asymptote we just said was, let's switch over to purple now. Switch over, it's x equals 1. The horizontal asymptote is the line y equals, now pay attention to this. Pay attention to this formula right here. Okay? You have your A and your C. In this situation, A is 4 and C is 1. So I have 4 over 1. And 4 over 1 is simply 4. You got to know that formula. 1, 2, 3, 4. There's my other asymptote line. And now I have to graph some points. I want to graph to the left of x equals 1, and I want to graph to the right of x equals 1. So they chose negative 1. If I put a negative 1 in there, I get 4 times negative 1 minus 2 over negative 1 minus 1. That's negative 4 minus 2 is negative 6 over negative 2. Answer is 3. So I have a 3 right there. If I put a 0 in there, that one ends up being really easy. Just negative 2 divided by negative 1 is 2. So I have the points negative 1, 3, 1, 2, 3, right there, and 0, 2, right there. Well, it looks like I'm going to have a branch that's going to go right through there. And then the other branch, conversely, is going to end up being right up here. All right. You guys go ahead and do the checkpoint. You got 2 problems here to do. And I would give you, give yourself a minute or so to graph those. Make sure if you're fooling around, those of you who are fooling around with your calculator, make sure when you put it in, you got parentheses around all your stuff. That'll make your life a lot easier when you're using your calculator. All right, hopefully you pause that for just a moment. And we're back, and when I look at what cannot be on the bottom of this fraction, where my asymptote is going to be, x equals negative 2, right there. Or I'm sorry, not negative 2, x equals 2. Bam, that's at h. That can't be a 0 on the bottom. That's the h, the x minus h. And my k in this situation happens to be 1. And so when I draw my asymptotes, hopefully you drew 2 and 1. 2 and y equals 1. Hopefully you drew that. And because this thing's positive, I should suspect that I'm going to have branches in these 2 areas. Okay, so I'm going to choose some points. I like to choose easy points. I'm going to choose x equals some number that's going to give me, when I divide 3 by that number, it's going to be easy. So if I do a 3, if I do x equals 3, 3 minus 2 is 1. 3 over 1 is just 3. 3 plus 1 is 4. So I have the point 3, 4. 1, 2, 3. 1, 2, 3. I have a point right up here. And that's in a good location, right? And if I choose a number a little bit bigger, maybe I choose a number like 5. 5 minus 2 is 3. 3 divided by 3 is 1. 1 plus 1 is 2. So I have the point 5, 2. 1, 2, 3, 4, 5, 1, 2. Branch looks like that. And hopefully you did the same thing on the other side and ended up with a branch that looks like that. If you couldn't do that, please make sure you ask that question tomorrow. That would be a vitally important question tomorrow. And let's take a look at this one. Now this one looks a lot like this one up here. This one, this ax plus b over cx plus d. And so I got to follow the rules that I just learned from example 3. So let's make it a little smaller on our screen so I can see everything at once. And if I look at that and I say, okay, in this situation, what can not be on the bottom of the fraction? So the first thing I'm going to do is I'm going to say negative x minus 2 equals 0, because I can't have 0 on the bottom of a fraction. That means negative x equals 2 if I add 2 to both sides. And then x equals negative 2. So I know right away I have an asymptote at x equals negative 2. Now, I don't know if I can draw this nicely. Oh, that's not too bad. X equals negative 2 is one of my asymptotes. The other asymptote, what's my A? Looks like A is negative 2. What's my C? C is the one I need. So my C in this case looks to be negative 1. And then when I divide those, negative 2 divided by negative 1 is 2. So my other asymptote is at y equals 2. Let's make that a little bigger again. And at y equals 2, right about there, I got another asymptote. Now, I'm not real sure. I got a negative on the top, a negative on the bottom. Where's this thing going to end up? I'm just going to try some points out and find out. So when I try some points, let me switch over to blue here real quick. When I try some points out, I'm going to let not going to pick the number negative 2, that's for sure. So maybe I'll pick something like negative 4, and I don't know how that'll end up. And maybe I'll pick something like negative 6, and I'll see where that goes. So if I put a negative 4 in there, I'm going to give myself some scrap paper here if you guys don't mind. If I put a negative 4 in there, I get negative 2 times negative 4 plus 1, and I get on the bottom, I get negative 1 times negative 4. I hope you guys saw that, or the opposite of whatever x is, minus 2. So I have negative 8 plus 1 is negative 7, over 4 minus 2 is 2. I get negative 3.5. So I have one of my points is going to be negative 4, negative 3.5. Alright, that's going to give me a real good idea of what's happening there. And so if I come back and I just do negative 4, negative 3.5, watch what I get. Negative 4, negative 3.5 is going to be somewhere down there. Well, that means it's going to look like this. Okay? And conversely, that means when I do all the work on the other side, it's going to look like that. I hope you guys took a minute and found those points. Perfect. Well, that's 8-2. That's a wrap. Great job. Thank you very much, folks, and we will see you tomorrow.